So now I am requesting Damija ma'am to kindly start the session, please, ma'am. Over to you, ma'am. Thank you.
Okay. Thank you very much, Rohit. So once again, we are all here to hear another versatile speaker, and as a part of the webinar series which we are hosting to celebrate the Azadi Ka Amrit Mahotsav. This is a Government of India initiative where we are celebrating 75 years of our independence, commemorating the glorious history, culture, people, and our achievements. And of course, this is dedicated to the people of India, who have been instrumental in bringing India to this level and to continue to, contribute as a global economic power. Now we have also landed on the moon. So we are the fourth country. So the progress which India is making or continuing to make is, you say noteworthy. Yeah, we can say we don't have words to express. We are progressing very fast and we are trying to, so we are grateful to all who have contributed to the success of all the projects and all the activities being done by Government of India or India at per se. And this Mahotsav is celebrated by some events like webinars, like we are holding webinars, some exhibitions, or there are some awareness events, even painting competitions. So a lot of activities now. I think it's spread all over the country, all over the world. And in Skill Council, we have decided to hold webinar series. We are a scientific, organization where we promote environment, we promote activities relating to renewable energy, waste, water management. And we decided that we will hold a series of webinars where we'll interact with learned people, experts in different sectors, and we will learn from them and also interact and see how our Skill Council can take these activities in these forward in these sectors. So waste is something, in fact, waste is synonymous with biomass. We have held, I think, more than 40%, though I can say, Mr. PV Singh, 40% of our lectures have been on waste or biomass. So that is the significance, that is the role, importance of this area. And what you are going to talk about, integrated waste approach, that is the circular economy, how the waste is not to be wasted, it is to be used as a wealth. In Skill Council, we have done a lot of sectoral studies in the waste, urban waste or in the rural waste. And we have come up with training modules, and we have also done the maximum trainings in the Waste Management Center. We have touched more than 4 lakh candidates, and it is all spread over 24 states in all the municipalities. So waste per se, you can say, as a part of the Swachh Bharat Mission 1, now 2, it is in an area which has, we generate a lot of waste, but then at the same time, this waste is to be taken as a wealth. And how we can collect it, how we can reduce the waste generation, then how we have to collect it, how we can reuse it, recycle it. So these are approaches which need to be adopted, and they are to be refined day by day. So I'm very happy to invite Dr. Richa Singh. She's I can say she's very versatile. She's a technologist also, and now she's also in the, in the field operations where she's managing the plants. So I think her topic today will really give us an insight how an integrated approach will be very useful to us when we manage our waste. So welcome, Dr. Richa. And very grateful to you. Skill Council is very grateful that you have accepted our invitation and given us this opportunity to learn from you and see how we can take this activity forward with your organization. Welcome once again. Now I request Mr. PV Singh to kindly introduce.
Thank you, ma'am. Thank you very much for welcoming the speaker and other participants. Good afternoon, everyone. I'll welcome you all to the 91 series of the webinar. The Skill Council for the Green Job is organizing a series of webinars to celebrate Azadi Ka Amrit Mahotsav as a part of India's celebration of 75 years of independence. In this series, SCGJ is inviting eminent and learned speakers in different sectors on sustainable development, renewable energy, waste management, so as to deepen the understanding of recent development in these sectors. The first in the series was launched on 24th September 2021. Today we have Dr. Richa Singh, a very experienced, learned, distinguished speaker who will be sharing his expertise and experience on integrated waste management approach. I would like to share her brief profile with all of you. Dr. Richa Singh completed her PhD in bioenergy from IKG Punjab Technical University and MTech in green energy technology from Pondicherry Central University. Dr. Richa Singh presently working as a manager project development in Blue Planet Environmental Solutions India Private Limited, New Delhi, and working as a centralized asset for evaluation, structuring, and conclusion of the waste to energy management domain projects at national and international platforms. Dr. Richa also worked with PECMA Air System Private Limited and National Institute of Bioenergy, Kapurthala. Dr. Richa Singh has more than 9 years experience in green energy technology. She is working in waste to energy domain, EPC projects, research and development and international national trainings. She provided technical supervision and management of operation and maintenance of biomethanation, decentralized plants for power and heat generation on different sites. Dr. Richa Singh published several papers, articles, books in different peer-reviewed journals, conferences, etc. She has got patented in method of producing biogas from lignocellulosic biomass. Dr. Richa has received some of awards in workshop, conferences, and trainings. Now I am requesting Dr. Richa Singh to start the presentation. Over to you, Dr. Richa.
Thank you so much, sir, for giving that much nice introduction to me. And thank you, ma'am, for inviting me. And thank you, all the dignitaries, for giving me the chance and opportunity to be the part of this series, Azadi Ka Amrit Mahotsav. Thank you all and good morning. So, I'd like to share. Is it visible?
Yes.
So today I would like to start with the topic integrated waste management approach. As we know that India as a country, it generates huge amount of waste every year. So according to one report, we have generated around 62 million tons of waste, from which only collected waste is 43 million tons. Other is not yet collected, and it's around 19 million tons. And the collected waste also only around 12 million tons only processed or treated. Other than that, it's simply dumped into the landfills. That is around 31 million tons. Every year, this is the situation which we are practicing every time. So, according to the resources, the per capita waste generation in India is around 0.25 to 2.5 kg per day. So this is, we can say, it's basically based on the income of the targeted population or the type of the targeted cities like Tier 1, Tier 2, Tier 3. So this So from here, you can imagine that how much waste we are generating every year, and this could be a huge problem. So the major problem which we can rectify from here is the waste collection and waste disposal. So if we see the challenges in this, especially in waste collection, the collection from the source, the lack of participation in waste and segregation at source due to low awareness. So the lack of awareness is the main cause of this waste collection. And second one is low waste collection fee. The wages we provide to the collectors, it's very low. So they also don't participate that much, that awareness is not there. And the awareness to the collecting people, they also not aware that what is hazardous and how to segregate it. And other is lack of infrastructure. Then lack of human resource is also one challenge we can see here. Then insufficient budget of solid waste management is another one challenge we are facing in this. Limitation of technologies. Suitable technologies, we are not aware, we are not aware of the technologies which is suitable, how to collect the hazardous waste or different types of waste. Then there are lack of institution and policy for solid waste management. Even though we have solid waste management rule 2016, but the awareness to how to implement it is not still to the common people. It's lacking. So which could be, we can say, the major problem in waste collection at the basic stage is waste collection. Waste collection could be at household waste, could be commercial waste. So if we put the segregation method, efficient segregation method here itself at the source, then we can rectify this problem efficiently. Then second problem which we discover here is waste disposal. How to dispose the waste? Simply what we are doing is dumping it in the landfills, which you can see here in the picture, that it will causes the air pollution and land pollution, and it's very unfriendly way of dumping the waste. It also causes so many human health hazardous problems. Then what are the objectives which we are going to discuss today is how to reduce the adverse impact on the environment of this waste. In both respect, how to collect it and how to dispose it, and in between, how to process it efficiently. Then second objective is to consider material flow in the society. And third, reduction in solid waste quantity, how to reduce the solid waste quantity. Then reuse of material, and the second last is recovery of material and energy. Then day-to-day solid waste management study, how we can make the strategy so that we can manage our waste. Especially here, I am discussing about the solid waste. So these are the categories we can divide our solid waste based on the material, what type of material, even it is organic material or inorganic material, or we can say biodegradable, non-biodegradable, that on the basis of the material composition or the type of the material, we can segregate, categorize that solid waste. Then based on the hazardous potential of it, we can categorize in the waste, solid waste. Then third is the source of generation. What is the source of generation? Here you can see the source of solid waste. is residential, commercial, industrial, municipal services, institutional, agriculture, hospital. Here in the picture, you can see that a huge amount of solid waste is generated from the residential part. So it's around 68%. Then you can see commercial is also contributing a huge amount of solid waste contributor, that is 14%. Then all the municipal services, education, agriculture, they also contribute a huge amount. It's around 12%. Then industrial waste is, separately, it's 2%. And then a hospital and clinics, which can come under the hazardous waste, it's around 4%. So what we have to remember here, the quantity, quality, and composition of waste depends on the source of waste generation. The composition of municipal solid waste in typical Indian cities. Here we can see the composition of municipal solid waste, MSW, in India. Generally, it's around 40% is food or garden waste. We can say it as an organic waste. The major part of the organic waste, food and garden waste, is 40%. Then paper waste comes around 27%. Textile is 6%, plastic, rubber is 4%, inert is 15%. It can be changed. Point of discussion is 15 to 10%. Then metals 3%, glass and ceramics 5%. So how to utilize this with the efficient methodology, proposed methodology, we can say, in the solid waste management rules 2016 released from our government of India. So this is a basic structure of methodology. Like we can collect the waste from different sources. Then under the second level is we can segregate it into according to their characterization, like biodegradable, non-biodegradable, and others. Then the third level in this methodology is transportation. Transportation is also considered as a big part of this methodology of integrated waste management, is how to transport it, because some solid part is bigger in size, and we have to reduce it, so that part is included in that. Pre-processing is included in that, and then transportation is, we can make the transportation efficient at this stage itself. Then fourth layer of methodology is processing, how to process that. Like for biodegradable waste, it's proposed that composting is one of the way. Then other processing, waste to energy methods are also there. So we can go for that also. And then how to dump it in efficient, scientific manner, so that it could be sustainable to our environment. Then I will discuss about each and every aspect of it, like integration, end-to-end solid waste management. How we can provide this end-to-end solution to the solid waste management, solid waste generated in our environment, in our society. We can see here that one approach of integration is commercial area or residential area. The waste always generated, we can collect it, and we can mechanically or manually we can segregate it to different types of waste and categorize it into, like here, organic waste, some dry waste, which is combustible in nature, and non-recyclable. So we can utilize this for some process, And then plastic waste is also one part of the solid waste. So we can utilize it and convert it into through some process to fuel. Then the remaining is inert waste, which we can, some part of it, we can recycle it and utilize it for some different useful products. And then the remaining inert waste we can dump into the sanitary landfills in a scientific way. This is a centralized processing facility, and here you can see the decentralized processing of organic rich waste, which through biomethanation we can generate the CBG for cooking or power, and the second byproduct of this process is fertilizer, or we can say manure, which we can utilize for gardening purpose or further. So this is a circular economy you can see generate from which we can get the benefit of this integrated processing of this solid waste management in a particular region, or the waste, the bulk waste generating or collecting site. We can do that. The second part is integrated landfill mining. So here we can say that the collection of waste in the landfills from where we can apply this integrated waste management strategy. So we can directly make it into these landfills into a good and a nice place for the environment. So the sustainability can resist here. So one part is if we get some landfill place, then first part of this methodology is pre-assessment and analysis of the dump site. So we have to analyze characterize this dump site. What is the composition of the waste? What are the different types of waste we can segregate from this? So first part is pre-assessment and analysis of this dump site. Then how we can stabilize this waste, what we get. Here you can see that this dump site is divided into several rows. So this is for the aeration we can provide to it to manage the landfills accordingly. Then the third process is processing and segregation. Different type of processes we can utilize here also. Like for organic, we can go for composting or biomethanation. And then for plastic, we can utilize the thermal processes and we can convert it into fuels. Then third is which is not recyclable, we can or combustible in nature. Then we can go for RDF, refuse derived fuels. From there also we can go for the power generation. And then the last one is the last category of waste is the inert waste, which we cannot recycle. So we can dump into the SLF, the sanitary landfill sites. So this whole is a important part of this landfill mining. So as I told, that first is pre-assessment and analysis of the dump site, then stabilization of waste, then processing and segregation, then last is responsible disposal of aggregates. So here you can see these are the processes, and here we can recover the products, important and valuable product like combustibles, fine soil, bioearth, coarse soil, stones, iron scrap, glass scrap, and etc. Processing technologies. These are the processing technologies. First, when we collect it, we call it material recovery facility. After segregation, every type of material we get and we segregate it, we can plan it, the recovery of each and every resource of waste we got. So we can say it as a material recovery facility. So here you can see that organic waste, dry recycled waste, plastic non-recycled waste, hazardous waste, and inert waste we get. So this segregation could be manually or can be mechanized. As we go to the higher capacity of the waste collection, we can opt for the mechanical part. These are the segregation or storage, effective storage strategy we can start. Like as we can see, the suggested storage effective strategy is to place the separate bins for different type of waste at the source. So here you can see different colors of bins can help us in separation of waste, like black for recyclables, yellow for toxic waste, red for non-biodegradable, green for biodegradable. Then we can go for, as I explained before, when we get the mixed waste, then what is the mechanism of processing of this mixed waste and utilize into or produce the valuable products from it. So this is the mechanism. Mixed waste, we segregate it into organic, RDF, plastic, recycled, inerts. Then organic, through biomethanation technology, we convert it into CBG or biofertilizer. Then RDF, from dry waste, we go through biochemical processes and convert it into power. And the residue of it is also utilized in different channels. I will explain it later. Then third is plastics. This is also convert into a kind of fuel that we call polyfuel. That's also work as a one kind of liquid and liquid fuels like gasoline and diesel. So the process is thermocatalytic depolymerization, TCD. Then the fourth part of this mixed waste could be recyclable waste, which we can recycle through different processes and convert it into valuable products. Then fifth is inert. Disposable to the SLF, sanitary landfills. So here, what is the important thing is through these products, we can generate the revenue, and this we call it a circular economy, from where each and every part of the waste is utilized and provide us a revenue and a source of revenue generation can. So this is a good example of circular economy, which we can say that is its integrated approach is a sustainable approach of utilizing all the waste into a opportunity. So this is one example of centralized processing facility. Centralized processing facility where we can utilize we can place all the technologies I have discussed before, and we can make it a centralized waste processing facility. So here we can utilize all types of waste using different types of technologies. These are the in detail process flow of biomethanation plant. One by one, we can discuss it. First is biomethanation plant for organic waste. Here you can see that a segregated organic slurry we fed into the digester, and the digesters will process it. We call it anaerobic digestion with the help of several microorganisms in the absence of oxygen. They produce biogas as a product, main product, which through biogas upgradation technology, we get a purified or enriched methane, which we can utilize as a product in several applications, like as a vehicular fuel, as a power generator, uh, and for cooking purpose. So, and this other byproduct, very valuable byproduct, is the digestate, which we can further process and convert it into organic manure. And the remaining part we can utilize, we can process into the ETP treated water for green zones. Okay, so here I can summarize that feeding to anaerobic digester, this organic waste, we can produce the valuable CBG and utilize into several types of applications. Then manure, separation and effluent treatment, then production of CBG for supply to vehicle and industries. Then second process is plastic to fuel plant. So how this plastic, which is a main concern of today's generation, that we are dealing with lots of plastic and as a waste, which is very hazardous to our environment and to human beings' health. So we can process this plastic into valuable fuels. And likewise, you can see here, we can segregate the plastic, shred it and fed it into the reactor, where the processing of this plastic happened at high temperature. Then it will convert into gases. We call it syngas, and again we can scrub it and sand it back. And some oil production is also there. So through this process, this oil we can use, we call it as a polyfuel, and we can use it as a liquid fuel. We are using the petroleum fuels we are using. We can replace it and we can utilize it in the same way. So this is the good utilization of this non-recyclable plastic through this thermocatalytic depolymerization process. And the oil generated can be used for multiple applications like heating or as a furnace oil. So apart from this biochar, this char is generated in this process that can be utilized for further industries for several uses. Then third is the dry waste, which we can utilize, or we can convert it into RDF, refuse derived fuels, from which we can generate the energy in the form of power. Here you can see the process, how this segregated RDF, where segregated waste will convert it into the RDF, and RDF fed into this furnace, and it will generate the power. And this power we can utilize for the electricity or energy generation. And the remaining, the byproduct of this process, whole process, is the ash, which we can utilize in the construction application. We can here you can see, we can process it and sand it to the cement plants, where so many construction facilities we can do that through this byproduct of RDF process. Then recycling of the recyclable dry waste. Here you can see the huge pileups of the baled dry waste, which we can again utilize and recycle and convert it into a valuable products. Then other one is this sanitary, the inert part, the inert type of waste, how we can dump it scientifically into the sanitary landfills. That is up to 10% as the norms of SWM is suggested that up to 10% you try to dump into dispose it into the sanitary landfills. So here you can see the site how these scientifically engineered landfills we can convert it into a sanitary landfill for the inert waste dumping. Other residue management, we can go for the ETP plant or wastewater treatment plant. We can see here the structure. This is the residue management, efficient residue management option. We can go for it. So the very important and next very important is this process is the monitoring part. Monitoring part, we have to take care for making this whole process efficient and reliable. So how we can do that? We can make this monitoring process online, the remote accessible. So here you can see that it's automatic. We can, from the initial stage, when the waste come in the processing site, so we need to wait, and so there we can place an automatic weighing system. Then that data we can collect through our online portal system, and then we can make the user ID, separate user ID for the persons who are making or monitoring this, and the organization who is responsible for doing that. We can make that monitoring live, remote access, through remote access, and making the user IDs. Then we can make it traceable through the GPS tagging system, and we can so that we can rectify each and every part of the process. Is it going smoothly, or there is any problem at every stage? Like we have to deal with the labor, we have to deal with all the manpower, and this segregation is happening properly or not. So all the data we can connect it through these kind of monitoring systems, which we can access it live, and we can access it remotely also. So parallel CCTV and PTZ camera monitoring system we can put, and with a complete backup for the project period. Then complete SCADA and PLC system for remote management of operations, that we can also do. So here you can see what else we can monitor and we can manage. So here I have shown you here the staff management, route management, live tracking of vehicles, site-wise waste quantification data, complaint reports, last mile traceability of waste, visual feed from processing facility, energy generation data from plant. All these things is possible if we put a efficient monitoring system at the site of the project. So then only we can say that it will be a successful in all the direction. So here you can see that the complaint system is also a major part of this. Complaint management is also a major part of this monitoring system, where we can report on number of complaints lodged on daily basis, report on number of complaints resolved and pending, ward or supervisor wise complaint pending reports, feedback reports, which is to be given to the complainant. So we can start one mobile app also, so that each and every issue will be traceable. Administrator MC can see some part of the operation reports through mobile app also. Photo we can upload, and we can trace all the things from there. Then I would like to show some glimpse of Blue Planet in that terms, what it is doing. Here you can see that the transform where we are the one company which is looking for the zero waste approach in managing the waste management with this integrated technology approach. Here you can see this landfill mining recovery of land from dump site, and we can set up some waste processing and upcycling plant where we approach all the proven technologies to process the solid waste, and we can go for the upcycling of all types of waste. And this is one solution. And when we process all the waste from the landfill, then we are proposing that the fresh waste, whatever is coming, we are able to process it from the starting point. So these are the salient features, like innovative technologies driving efficiency and effectiveness, the synergies between technologies for a comprehensive 360-degree solutions, then ESG complaint practices with last mile traceability, cutting edge system for optimized resource utilization, then end-to-end solution for all waste streams. These all are the services we are providing, like green energy. In that biomass, organic, or whatever mixed waste we are getting, we are converted into green energy, and some other part of the waste we are converted into energy. So we can call it waste to energy solution. Then second services is remediation, recovery, and urban mining. That is it covers all the aspects of landfill mining and the processing, and converted it into utilized, into useful products, and the byproducts we can recycle it, and again we can make indulge into the circular economy likewise. Then third is collection services and MRF. Then here we also do the collection services, and we do the material recovery facilities. Then fourth one, last one, is consulting, education, and specialized services also we provide. So some of the case studies I want to show here is a good example of integrated waste management solution. In the Janeda Authority, we have developed one integrated waste management. It's a good example of circular economy model for sustainable solution, end-to-end services. Here we provide collection, processing, and disposal of waste, state-of-the-art technology deployed for efficient operations, compact and scalable design to suit diverse needs, centralized monitoring with online end-to-end traceability, sustainable waste management for a cleaner future, promoting a circular economy and resource optimization, green solutions with a focus on environmental preservation. This waste management system can divert 7,000 to 10,000 tons of waste per annum from going to landfill. scenario. We are now planning to deploy a scaled up version of the same mechanism in Kerala. This expanded approach has the potential to divert an impressive amount of waste ranging from 70,000 to 100,000 tons annually from ending up in landfill. So these are a few examples of landfill mining here, how you can see that before what is the situation and after approaching the same, we how we renovate it into a environment friendly landfill, and we can say that here we can utilize the land resource and we can convert it into a resource of different which we can utilize for further facilities. Like here, you can see at this land site and how when we do this landfill mining approach and how it will change the scenario. Here in the last picture, you can see that at Noida, this dump yard, it converted into a beautiful park and beautiful resource of the region. This is a circular economy example, like how I told that different types of waste we convert it into useful products. Like here you can see we from these plastic waste we shredded and compressed it and converted into beautiful furnitures which which are utilized in the schools. And here the bricks, pallets, the constructed debris, we converted into the brick pallets, which we can utilize for construction purpose again. And here heavy duty industrial products, we converted into these kind of products, then plastic to fuel from which we can run the vehicles or we can run the industry. The energy, and then RDF. Here you can see the ash we send it to the cement industries, where again it will utilize into the industries as a useful product. So these are some decentralized organic waste solutions where you get the compact modular product with customization, more than 120 plants delivered, in-house designing and R&D by technical team with global expertise, equipped with online monitoring system and global standard components. So these are the achievements, few of our achievements. So I would like to thank with this whole presentation. Thank you very much.
Thank you very much. And it was a beautiful presentation. And I'm very happy that your company has adopted a very, a complete approach to waste management. In fact, the first in the monitoring I saw was the weighing, the weighing of the material. So I think that is also very important. How much you are collecting and how much you will ultimately be able to deliver. But this biomining in Gazipur also, you are involved in biomining landfills?
No, no, ma'am. Gazipur we didn't approach, but there Noida we approach in northern part.
Okay, so how much? What was the landfill size and all that in Noida? Huge.
Here you can see here. Sorry. Can you see the screen, ma'am?
Yeah, of course.
Yeah,
not full, but yeah.
Okay. So here we process this around 99,665 metric ton legacy waste, and it's like
you processed it, and then what did you do? You took it into a biogas plant, or?
It's like because legacy waste consists organic waste as well as other type of waste also. So legacy
waste.
Yeah, so organic waste is one part, and other part also like RDF we are also doing, and then recycling also it's one part. of it. So our approach is integrated in terms of managing all types of waste. It's not only the organic, all types of waste.
Yeah. So there are certain comments and some queries also. First, they said that most of the waste, this is from Ashwarya, most of the waste actually goes to dump sites due to lack of sanitary landfills, which are required to be in compliance with the Solid Waste Management Rules 2016. So would you like to comment on this? I think we don't have any landfills. We don't have any space for landfills. So
Yes, so that's why this integrated approach should come into the picture. We already started that approach, and so there is a scientific engineering how to dump this inert waste, or we can say sanitary landfill. There is a scientific approach to do that. I can show some pictures.
You have to mine it.
Yeah, so here you can see that how we cover the, so that leakage should not be there. So again, if we dump with unscientific way, again we are polluting it. So we should think about it, and there are proven technologies to dump it in a scientific way. So that approach we have to do, and that awareness, it's must. Yes.
But pre-dumping also, you line it up and you don't allow the leaching to the soil, no water, the toxins going into the soil. I think you may make a bed and all, then only you do it for the pre-landfill. You have shown one slide now. Yeah.
Yes,
so
yes.
The second is that I think this is from Mr. Royston. He says, I think the system will work wonders if we can create awareness and segregation happens at source. Yeah.
Yes, true.
So
agree with that.
So much of effort is being made in RW also. We can't give mixed waste. We have to segregate wet and dry waste. There's a fine. He takes a photograph and he goes and puts a fine on us, 500 rupees for every thing.
Yes.
So that is a
when something goes from the pocket, then only that's a human nature. Then only we will be strict.
He told one day, he said, ma'am, I'll take a photo. Some plastic was there in the. So then we said, okay, you please don't do it. From tomorrow we will never get it. So there's one thing from Dr. Raman. He says, is there any emission analysis done when using the waste plastic driven liquid fuel? When plastic to liquid fuel, have you done some emission analysis for the emissions?
That data I can provide. Please contact me like individually. So I will provide that data if you like. That is, of course, with the technical team, it's there.
Okay. So I think either you can put your email in the chat box, and there's a demand for your slides. Your slides from Dr. Srinivas also, and Mr. There's one more person, Tharu Ganan Mabase. Yeah. So
sure.
Ma'am, Dr. Srinivas is hand raised. He wants to.
They're asking for the slides now.
No. I also wanted
Dr. Srinivas, please.
Thank you very much, VB Singh. Thank you, madam. Dr. Richa, I think you have done a very good presentation. Not only the presentation comes out of the work that you have done. Many compliments to this work, because a lot of talk is around waste, but you really have gone into making it as a business and thereby solving the problem. Excellent work. What I want to ask you is, I'm involved with an agency in a foundation who are trying to do net zero universities, net zero emission universities. That is an entity called Green Terre Foundation in Pune. So they have already enrolled about 150 universities. So, your scale of operation, you are doing at a larger scale. Is it, the same set of modules to solve at the universities level, where say 20,000-30,000 students may be there? Do you have a module for that, which is like techno-economically feasible? Just the way other day in a workshop, ESL came up with a solution that to decarbonize in a university, it will, these are the things that you have to put forth, and the cost is 5.72 crores. So a message has gone to the vice chancellors. Okay, if you want to decarbonize, this is what happens. Now, similar message, if it has to go, do you think a module for universities could be quickly developed? You can compost this much, you can produce biogas this much. Finally, this much can go out of the their gate, let's say the boundary. So, do you have any suggestions for that? Over to you, Dr. Richa.
Sir, rightly said that there must be one awareness module, and university or colleges that is the right approach so we can educate our next generation in the right direction. So definitely we will work for this, and we can jointly and we can make some strategy how we can make some model to give that awareness to the next generation at your place. So, yeah.
Thank
There
you.
is one, yeah. Thank you, Dr. Srinivas. I think Aishwarya wants to visit your some of your facilities. So, is
Sure,
it
ma'am.
possible?
Yes, ma'am. Yes, ma'am. Most welcome.
So her
please.
email ID is already there in the chat box. She's put it. So all of you
Yes.
can independently interact with her and ask for the presentation. Is, I think, a big hit. Everyone is asking a copy of your presentation. So if you are comfortable, you can kindly share it with them. Karbi Datta is also asked. And, yeah.
It will be
And,
better if I will share it to you,
yeah,
and
yes.
likewise.
Okay,
Yeah.
okay. Yeah. Okay. But they can write to you independently. 2-3 people are there. You can write to you independently. And anything else? Anybody else wants to ask something? Any other queries? I think it was a wonderful presentation. The integrated approach. It was very inclusive. It gave everything into, and the biomining concept, that is very important. It has come up
Yes.
lately, but it is, the Ghazipur, I don't know how many years it will take to come down.
Yeah, there are so many issues related to that
Yeah.
because municipalities are involved in that. So some shortage.
No, but it's very
of-
difficult. I have been to that landfill,
Yeah.
and even standing close to it, because there were some projects which were coming up for processing it, because it's a local global warming that is happening around the landfill, and I think how people are living there, it's very difficult. So the earlier it is done, and then the fires which happen, the disease,
Yes, ma'am.
you know,
Yes.
and then the general immunity of the people who are living close by, it goes down.
I think in urban area, that's the main issue with dealing with this. We don't have lands and we are filling it with waste. That too, it's creating so much of problem. So we have to deal with that in a scientific way.
Yeah, I had visited a landfill in Sweden, and I saw the way they had removing all the mechanical things, and then of course, and they were saying the land prices near a landfill are very low because nobody wants to live near a landfill. So that is the type of realization. But here we already are short of space, so by compulsion, people have to live around the landfill. I think this biomining thing will really help, and RDF, of course.
Yes, yes.
It's a huge pile. It's a huge pile. I have visited the Selco plant in Hyderabad for RDF.
Okay.
So you can't go near the plant. So much of municipal waste is collected. They need the municipal waste to have a complete sustainable supply for the RDF. It's a big challenge working up in these plants. So take care when you go and set up these plants. I think Mr. Amrit Pal is there. Would you like to ask a question, Mr. Pal? Right. So with this week, I would like to thank you, and thank you for accepting our invitation, and
Thank you so much.
Yeah, it's a very wonderful presentation.
Ma'am,
We'll connect in future. Yes,
Ma'am,
please.
yeah, Dr. Subra wants to know, do you take a student for internship, Richa?
In Blue Planet? Achha, this is Subra Das. She's from
Subra Das.
Amity University. She's in the
Yeah.
energy department in Amity University. And
Okay.
I think Dr. Subra, if you're there, you can talk to her, give her more details. Dr.
Yes.
Subra? Yeah, please.
That will be good.
Yeah. Dr. Shubhra Das, are you there?
Yes, yes.
Ma'am,
Please give her speaking rights. Yeah. Hello, how are you?
I'm good, ma'am. I was listening to the talk. It is really the biggest problem that all of us should address. So I was just wondering whether your company would like to take some interns. And if so, then what is the process?
It will be better, ma'am, if you could have reached through mail, so we can officially suggest you the process in that way, because
That
we
means-
have one department of skilling also. So in that way, how we can both mutually can utilize the things.
So that means, Dr. Shubhra, yes, they can take, but the process has to be, worked out.
Definitely.
That would
Especially
be
when they're doing projects in Noida, Greater Noida. So they're close to your place also. Students can
I
learn a
saw
lot.
it's in Curiosity.
Yeah.
Yeah. So if you can share your email address, or I can take you from ma'am.
It is there in the chat box.
I have placed in the chat boxes.
Yeah. Yes.
Thank you so
Once
much.
again, yeah, thank you very much. Thank you, everybody. And Mr. P.P. Singh will now say his formal vote of thanks. Yeah.
Thank you, ma'am. Thank you. I would like to request Richa to share your presentation to me.
Yes.
And because so many people are asking your presentations. Okay. First, I would like to thank Dr. Richa for accepting our invitation for the presentation. Thank you, Dr. Richa, for the excellent presentation. It's very informative and knowledgeable. Hope all the participants are get benefited. Once again, thank you very much, Dr. Richa. Now I would like to thanks all the participants for their valuable presence and support. Thank you very much, all of you. Especially, I would like to thank Dr. Subradas, Dr. Dasan Srinivas, Dr. Narendra Kumar, Dr. P. Raman, Dr. Ramilpal. They are regularly joined without fail. Thank you all. Thank you very much. Also, thanks to Mr. Rohit for the IT related help. Finally, I'd like to thank Dr. Dhamija ma'am for the support and guidance of the webinar. Thank you all. Thank you very much.
Thank you, everyone.
Thank you, everyone. Thank you. Have a good day. Thank you.
Thank you.
Thank you, sir. Thank you.